So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and Mastermind Schools. Once again, welcome all the class 9 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9th, our ongoing chapter, Basic Math in Physics. Today we are entering into session number 5. So far we completed 4 sessions in understanding what is the importance of mathematics in understanding the physics. In that we discussed about the few important chapters of mathematics and their formulas and how to apply in physics. So we'll continue where we left in the last class. Right. So in this process, we discussed about the trigonometry, right? We discussed about all these topics we discussed in the last 4 sessions. What is the importance of mass, all the angles and types of angles, conversion of degrees into radians, and trigonometric functions, trigonometric ratios, rules of triangles, differentiation formulas. What is the differentiation? How to differentiate the given terms? Different only formulas only. Then also introduced about the integration. See, the differentiation and integration, it takes a long time to make you to understand. As you can take the help of your mathematics teacher to understand the formula first. So there are some formulas are given. We discussed in last class about differentiation and in the introduction of integration. If you are perfect in that formulas, you can differentiate or integrate any given one. So that will take, you have to take some step to understand them with the help of your mathematics teacher. In meantime, we'll move to the next part of this chapter. After learning about this, we'll go for the next part where we discuss about the vectors. After integration, after knowing about the differentiation and integration, important formulas, just note down all the formulas of differentiation, all the formulas of integration, and you can solve that worksheets as according to the formula. How to apply the formula in given equation. By applying directly, you can write the answer for that. Okay, you make practice after that. And if you have any query, you can ask your mathematics teachers. They'll help you, they'll guide you. Okay. Now, we'll come to the next topic, next part of this chapter, which is vectors. Vector also is the most important part of mathematics. Actually, there is a vector mathematics is the separate chapter in vectors, but it is also connected with the physics. Why? Because all the physical quantities, already we learned in lower classes, all physical quantities are nothing but the quantities which can be measured. The quantities which can be measured are called physical quantities, which are mainly classified in 2 categories. We learn in lower class, that is fundamental physical quantities and derived physical quantities. Is a one classification. Another classification also there. All the physical quantities are classified into vectors and scalars also, based on the whether they have only magnitude or magnitude and direction. The physical quantities which have only magnitude, no direction, are called as scalar quantities. The quantities which has both magnitude and direction are called as vector quantities. Right. So here we have very importance for the vectors in mathematics. So what are vectors? What are vector quantities? What are the different types of vectors? Okay, that all we discuss here before concluding the chapter. Still so many are there to learn in this. See, in our study of physics, we often need mathematical tool to work with the physical quantities. One such mathematical tool is vector. Physics deal with the many quantities that have both size and direction, and it needs to be special mathematical language, the language of vector, to describe those quantities. This language is also used in engineering, navigation, purpose, and other science, and even common speed. In this chapter, we'll deal with the general properties of vector quantities. We discuss addition, subtraction, and multiplication of the physical quantities together with same common application. A physical quantity means anything that can be measured or property that can be quantified. They are called physical quantities. All these physical, see, in physics, we deal with the two types of physical quantities. One is scalar and other is vector. So what is scalar? The physical quantities which possess only magnitude are called scalars. There is no direction. For example, mass, length, time, temperature. All are considered scalar only. A scalar is represented by numerical value. For example, mass. Mass is 2 kg. Numerical value alone and scalar combined the one another to law of ordinating the arithmetics. So scalars can be combined or addition of scalar, subtraction of scalar is possible. Scalar quantity can be added, subtracted and multiplied by simple law of algebra. So vector algebra is separate chapter in mathematics. We can add when two scalar quantities are given, we can add them, we can subtract them, we can multiply them also. But our focus is on vector quantities now. The physical quantities which possess both magnitude and direction. Also follows laws of vector addition called vector physical quantities like displacement, velocity, momentum, force, and acceleration. All these are having not only magnitude, not only number, it also having the direction also. Northeast, southwest, towards south, towards north. They'll mention specific direction is mentioned in the case of all the vector quantities. Right? So all the physical quantities which are available in physics are classified into scalar quantities and vector quantities based on whether they have magnitude or magnitude and direction. Physical quantities which have only numerical magnitude are called scalars, right? And the scalars can be added, subtracted, and multiplied, whereas vector quantities are those which have both magnitude and direction. Okay, that is a classification. So see here, how to represent representation of vector. Now, for example, scalar now, type B. So geometrically, the vector represented in line with arrow indicating the direction. Why arrow here? That arrow indicates the direction. The tail, length of the tail is the magnitude. So suppose this is one vector, this is another vector. Meaning, what is meaning? The length is small, means magnitude is small. Suppose say, and direction is 2 meters towards north. This is 10 meters towards north. So magnitude number is more for compared to this and this, but direction are mentioned. But this is represented by head and arrow, head and arrow and head. All space. Why head is this arrow indicates that is a direction. So tail, head. Head indicates the direction, tail indicates the magnitude. If a vector is displaced parallel to itself, it does not change. If vector rotated through an angle other than multiple 2 pi, 360 degrees, changes. It changes. After rotating, the vector value changes. So that will come across later when you are solving few problems, right? So vector can be represented by a line with arrow. The line indicates the magnitude, arrow indicates the direction. Tail, head. Right? Then there is a types of vectors, very important to understand the vectors, types of vectors. Before going for this, I will show you one video on the same. After the video, we can go for the right.
Scalars have magnitude, no direction, and they obey the laws of ordinary algebra, right? Scalars. First example is distance traveled. Distance traveled is a scalar. Speed is distance traveled per unit time is a scalar. Temperature pressure. Both are scalar quantities, right? Pressure is perpendicular force by area, normal force per unit area is pressure. Pressure has got a direction which is unique, so pressure is a scalar. Mass is a scalar. Energy, all kinds of energy, potential energy, kinetic energy, all are scalars. Work done is a scalar, right? Anything having the word potential, like electric potential, magnetic potential, all are scalar quantities. Electric current is a scalar. Some of you may start thinking how electric current is a scalar, right? We give arrow to the flow of current. But if a current of 3 ampere is going like this, and a current of 4 ampere is going like this, always we get 7 ampere. This does not depend on the orientation of these wires. You keep on changing the angle, still you get 7 ampere. So electric current does not obey the laws of vector algebra. So electric current is a scalar. So all these are scalar quantities. Now let us look at vectors. Vectors have got magnitude, they have got direction, and they obey the laws of vector algebra. That is important. Okay. So we start with displacement. Displacement is the first vector that we can think of. Displacement per unit time is velocity. Velocity is also a vector. Rate of change of velocity is acceleration. Acceleration is a vector. Mass into acceleration is force. F equal to ma, Newton's second law. Force is a vector. Mass into velocity is momentum. Momentum is a vector. Force into time is impulse. Impulse is a vector. Torque, the turning effect of a force, is also a vector. Torque is force into perpendicular distance. Suppose this pen can rotate about this hinge, we can say, right? If I apply a force like this is creating some turning effect. That turning effect is called torque. Torque is a vector. So remember these examples systematically, then you'll not forget. Vectors, first you think of displacement. So displacement is a vector. Displacement by time is velocity, that is a vector. Rate of change of velocity is acceleration, acceleration is a vector. Force is mass into acceleration, that is a vector. Mass into velocity is momentum, momentum is a vector. Force into time is impulse, impulse is a vector. Force into perpendicular distance is torque, torque is a vector. Anything having the word field, that kind of physical quantity is a vector. Electric field is a vector. Magnetic field is a vector. Gravitational field is a vector.
So these are
All
direct
these are
used in specific
vector
direction.
quantities.
So they are placed under vectors.
Now there is a quantity called finite angular displacement. Okay, that's a quantity that we learn in rotational mechanics chapter. This finite angular displacement, what does it mean? If a pen is like this is a zero angular position. It moves from here to here. It has moved by some theta. That we call it angular displacement. Finite means it is not very small, it is reasonable. Okay, that finite angular displacement is not a vector. So remember this, finite angular displacement is not a vector because it does not obey the laws of vector algebra. This you going to learn in detail when you study rotational mechanics chapter. For the timing, you remember.
Right. So these are the few examples of vectors and scalars, right? So one more is there, I think. We'll see one more video on this, on types of vectors. So various types are there vectors, where we can see about the what are the different types of vectors, different types of scalars, which is explained here. Okay. So okay, anyway, we'll see. Right. So when you see the types here, there are different types of vectors are there. Types of vectors. Try to understand the diagrams also given. Equal vectors means when the vectors are said to be equal. If two vectors have equal magnitude, magnitude means length and direction, same direction, then they are said to be equal vectors. See here, A, vector B is there. So both are having same length and same direction also. See, same magnitude, same direction. If any vector is represented by same magnitude and same direction, they are called equal vectors. Very, very important. It is helpful for you even in mathematics also. Next, like vectors, like the vector which have same direction irrespective of the magnitude. Magnitude may be different here, see, but the direction is same. When the two vectors moving in the same direction, irrespective of their magnitude, they are called like vector. For example, one is this A, one is B, any number it may be, one is C, one is D. So what is it? They all look same direction. The directions are same, but their magnitudes are different. Even though they are called like vectors. If both are same, they are called equal vectors. If direction is same, magnitude is different, they are called like vectors. Next, the vectors which are mutually opposite in direction are called unlike vectors. See here. So one is A is going this side, B is going this side. They are called unlike vectors. The vectors which are mutually in opposite direction, are called unlike vectors. Clearly you can see, right? Unlike. Negative vector, the vectors are mutually opposite direction, but they are having same magnitude. See here, magnitude are different. They are moving opposite direction with same magnitude. Magnitude is same for both. Length is same, but direction is opposite. Then they are called negative vector. Negative vector. Very interesting. And fifth one, co-initial. Initial means they starting from same point. See here. From O, they are going to A, B. Three vectors are starting from same point, moving in different direction. The vectors which have same initial point origin, irrespective of their directions and magnitude, are called co-initial vector. Co-initial, same initial point. Initial point is same here. They all start from same point but going in different direction and different magnitude. They are called co-initial vector. Very interesting, right? Now, some are there. Co-terminal vector. Co-terminal. They are coming from some distance and they are terminating at one point. They are coming from some other place, but they are meeting at one point. Any number, irrespective of magnitude and direction. Co-terminal. Co-initial means starting from same point, going different directions. For example, see, when you go to the railway station, there are so many trains to start from railway station. All are starting from same point. One is going to Vizag, one is going to Chennai, one is going to Tirupati, one is going to Vijayawada. So what is happening here? Starting from same point, moving in different directions. They are called co-initial. At the same time, a train is coming from Bhubaneswar, a train is coming from Bangalore, Chennai, all they are coming to Secunderabad railway station. That is, they are called co-terminal vectors, starting from somewhere and they are meeting at one point, or moving from the same point, going to different directions. So co-initial, co-terminal. Try to understand. The word itself gives a clear meaning for you. Right? Okay. Now comes unit vector. Unit is one. A vector having unit magnitude of 1 is called unit vector. If A is the given vector, then unit vector is given by A arrow, you can see, A cap. You can call it as cap is equal to given A by mod of A. Mod means square will get. That will solve any problems will come. The unit vector along x-axis, y-axis, and z-axis are denoted by ijk. These are orthogonal unit vectors. So mod is called mod I is equal to mod j is equal to mod is equal to 1. That we'll see later when you are discussing the problems. Zero vector. A vector zero magnitude is called zero vector or null vector. No, there is no magnitude, but direction is there. So direction of null vector is independent. Proper vector. The vector whose magnitude is not equal to 0 is called proper vector. With 0 is called zero vector. Not equal to 0, proper vector. See how beautiful and easily understood terminology. Position vector. Right? So position vector is one kind of vector. The position vector at a point specifies the position of the point with respect to coordinate system where the point is located. That will come across when you are solving the problems. And point in the space. Its direction is towards the point and its magnitude is given by distance between the origin. Will come across the coordinate system. Coordinate geometry will come across how to find the distance between origin to the point. Either 0 to here, 0 to x, 0 to y, or whatever it may be. Right? The formula also you can see here for finding the unit vector. Coplanar vector. Coplanar. Co means same. Planar means plane. Along the same plane. Right? Coplanar. The vector which is lying in the same plane or parallel planes are called coplanar. See, they are saying the same plane, so it is called as a coplanar. Non-coplanar. So these are the 12 type of vectors are there. 12 type of vectors. You can understand. This will come across in the vector algebra chapter also for you in your mathematics, where you need to know about this. So please copy all these things before going for the angle, how to find the angle between the two vectors. The formulas are there. Vector addition, vector subtraction. Before that, first you note down these types of vectors in your notebook along with the diagram so that you can understand easily. Right? So start with first one, equal types of vectors. Equal vector, like vector, note down the order. Equal vector, like vector, unlike vector, negative vector. Up to that, right? Next, we'll move to the next one. So diagrams also, the diagrams clearly makes you to understand the definition. Okay. Next, we'll move to the next one, fifth one. Co-initial vector, co-terminal vector. I give a beautiful example for you, either railway station or bus stop, where many of the trains and buses starts from one place and move to the other places. At the same time, they are coming from different places, they are meeting at one place. Please maintain the notes properly with all worksheets also you have to complete. If you have any query, you can check the key provided to your teachers. So these 5 sessions and maybe 2-3 more sessions to complete this chapter to feel like a mathematics class. Then we'll enter into our real physics. Tail and head. Tail indicates the length of the tail indicates magnitude. Head indicates the direction. We are at the page number 24-25. A few more are there to complete the chapter. Okay, then unit vector. Hope all of you are having the material also with you. If not, you can purchase the material immediately, because point to point we discuss from the material only. So there are totally 11 types of vectors we can see here. 11 types of vectors. Then you can find the angle between the vectors. Very important formula. Then we'll discuss about what is addition vector, subtraction of vectors, multiplication of vectors also. It all satisfies the vector algebra in mathematics. Right. If any time is there, you can. So how to find the angle is given here. To find the angle between 2 vectors, the 2 vectors from a point are drawn such a way that their arrowheads should be away from the point. See here how nicely. So that we'll discuss in the next class, how to find the angle between the vectors and vector addition and subtraction, multiplication of vectors, right? These are the topics left in the vectors part. Then after completing vectors, we'll have the how the vectors, resolution of vector is very important in physics also. How the vectors are divided into horizontal and vertical components. So it's purely, we have one for parallelogram law here. From that law, it's triangle law of vectors, parallelogram vector, polygon law of vectors. Different laws are there. So with that laws, you can finish up the chapter. Okay. Resolution of vector is the last topic of this chapter. So after that, you have to solve all these. Then we move to the second chapter, motion. Right. So that's all for today. What we learned about the vectors and types of vectors. Right. And different types of vectors. We have seen 12 types of vectors. And practice them, which is helpful for you even in mathematics also. So that's all for today. Thank you, students. Have a wonderful day. Thank you.